Hello, my name is Aditya Pillai and this is Lab Report 3. The purpose of this lab is to observe and learn about magnetic fields through visual representation, to observe the relationship between distance and magnetic field, and to use the distance relationship and Biot-Savart law to find the magnetic moment of a bar magnet. The fundamental principles we use are that a bar magnet acts as a magnetic dipole, that Biot-Savart law is equal to b u naught over 4 pi times 1 over r cubed times 3 times u dot r hat times negative u. The results were that u equals approximately 0.006 and that n equals negative 6.0823. The system in our lab was the bar magnet and the surrounding was everything else. Our initial conditions had the bar magnet and the magnetometer on the phone, and our setup was that the location of the magnetometer on the phone was pinpointed by sliding the phone on a ruler to find the strongest magnetic field on the x and y direction. After we found the magnetometer on the phone, the on-axis of the bar was found using a ruler for several magnetic field values, which are linearized by taking the natural log of each side and then graphing as shown above. We then found the off-axis magnetic field by finding the d-perp to give 100 microteslas and then moving it more perpendicular to give a 45-degree angle. Some of the observations made were that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnet moves closer, the measured x component of the field increases, and that the position of the phone matters in terms of ensuring the magnetic field of the Earth doesn't interfere with our readings for the magnetic field of the bar magnet, especially the orientation. From the calculations, from the graph, we get y equals negative 6.0823x minus 20.587. From this we get n is equal to the slope is equal to negative 6.0823. Natural log of k is equal to negative 20.587 according to earlier equations, so k equals 1.14589 approximately times 10 to the negative 9. Biot-Savart law allows us to find u. When r equals 1 m, and we set the law equal to the distance-dependent equation and solve for u, we get that u equals 2 pi times k times r to the n times r to r cubed over mu naught, which gives us 0.005729 or approximately 0.006. As part of this lab, we were given a starter code. In that code, we made a function to determine the magnetic dipole effect at any point, as well as graphed arrows at several different points and showed the effect of this magnetic dipole in their direction. And using this, we calculated a off-axis one at 45 degrees, which is the purple one, which we will then compare to our observed one to see if this model is accurate. So when we compare the theoretical off-axis of 7.00 times 10 to the negative 8 to the actual off-axis of 3.63639 times 10 to the negative 5, we find that we're off by about 3 orders of magnitude, which is a very significant difference. So as stated, there are significant discrepancies with our model comparison to our actual. In our model discrepancies, the bar magnet's magnetic field is normally very close to modeling a magnetic dipole, so it should yield accurate results. However, some possible sources of error were that the location of the magnetometer could have been incorrectly calculated, or that the phone was skewed by movements, and that there may have been an electric conduit in the table that was unaffected or that didn't get observed by the measuring of the Earth's magnetic field, but it went unnoticed during the orientation at first, possibly becoming more of an interference as we moved a little bit, as nearly all tables of the clock have some sort of wiring running through them, enough to generate an opposing or interfering magnetic field. As part of this lab, we were given 2 questions to try and answer. The first question is, what if we hadn't oriented our experiment to compensate for the magnetic north and had instead laid our meter stick at some intermediate angle with respect to the Earth's magnetic field? How would this have changed our results? Well, there would have been interference from the magnetic field of the Earth, and we would have it as a result necessary to subtract the effect of the magnetic field at every measurement in order to try and compensate and standardize the results. The other question was, what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? Well, if you were to stick 2 magnets together, they would essentially fuse into a larger dipole with twice the magnetic field moment, and they would combine to create essentially a larger magnet. This would just create our measurements as being twice as large and having a stronger magnetic field at every point recorded. Thank you for listening to my lab.